Okay, morning level twos. So this is a little educational lesson on steering systems just to help you with your LVO4 chassis technology phase test. So some of this we've been through, so I'm going to skim over the stuff I think we've been through. I'm going to highlight some key points that I think you need to pick up. And ultimately, I'm just going to give you a rundown and a breakdown of steering systems at level 2. So let's just crack straight on with this. Bear with me a moment. Let's bring that up as a slideshow. Okay, so first thing to identify is obviously steering geometry, how we set up steering geometry to allow the vehicle to behave the way we want it to behave when we are driving a vehicle in a straight ahead direction, but also when we're navigating a corner, whether that be left or whether that be right, to make sure that we are using the full contact patch of the tyre and make sure that we are accounting for any forces that may be acting on that car when we go around a corner, when we accelerate, when we brake. So first thing to understand, I hope you all know this, you should do from level 1, Ackermanns Principle. What we're looking to do with Ackermanns Principle is achieve something called true rolling motion. And what that is that's when the tyre rotates and we allow both the wheels to rotate at different speeds on a steered direction, i.e. left in this case. The reason why we're doing that is because we need to make sure that both the wheels go through different circles, okay? And different circles are going to have different circumferences and they're going to have different angles at which we need to point the wheels to move them through those different circumferences. This is why we have the inner wheel turning through a greater angle than the outer wheel. By doing this, what we're allowing minimum tyre scrub. So the car is able to articulate itself, left-hand corner, it goes round, it spins, and we're able to see that, okay, on this diagram here. And you can clearly see here that the inner, okay, is going through a tighter angle than the outer. Should already know that, just going over that just to make sure. I'm going to use my hands a lot. I know that sometimes you can't see them on the camera. Forgive me. It's just I'm not used to doing this, and I much prefer being in a classroom, of course. Okay, so the other thing to notice is toe in and toe out. You need to understand we're looking from the top, and what we're looking at is the way the wheels either come in or the way the wheels come out. Okay, and this is all to do with tracking the vehicle. When we talk about tracking a car, this is what we're talking about. You need to understand why we track a vehicle. You need to understand how we track a vehicle, which I've been through in class, read your notes, and also the prerequisites, things that we're going to look out for, things that might cause the tracking to say it has a problem, but it actually is something more sinister. Like, for instance, a bush has gone on the suspension system, or the rear axle has been twisted slightly or misaligned, or there is a problem with the tyre pressures. All of these things could cause the customer to think there's something wrong with their steering. So we need to check all of this, obviously, before doing tracking. Make sure you understand how to do that. Okay, with the camber, we spoke about this again, when viewed from the front or when viewed from the back, but usually we say from the front. We're looking at the vertical tilt of the wheel in correlation to the vertical axis. So what you can see here is you can see a positive tilt or you can see a negative tilt. Generally, vehicles that we tend to work on have negative camber. The reason for that is that when we go around a corner and we have the forces acting upon the wheel, the negative camber allows maximum contact patch between the tyre and the road, giving us maximum stability and maximum grip when we turn around a corner. And that's ultimately what we're looking at. Obviously, positive camber here, usually fine with vehicles with fairly heavy loads, because obviously as the weight sinks and sits onto the suspension, what we're going to have is we're going to have a slight movement on the road wheel, and that is going to cause it to come back in. And again, we're looking to maximize that tyre contact patch with the road. Caster angle, this is when viewed from the side. So we're looking at the car, we're looking from the side. And I think I've been over this before, but the best way to think about caster angle is to imagine a shopping trolley. You know the old shopping trolleys that they have the metal stanchions that come down straight over the caster. Now when they do that, they don't have a caster angle. And you think about how a shopping trolley behaves. The wheels are doing this constantly. And the wheels can't really make their minds up which direction they need to be travelling in, because the weight of the trolley is having an impact on their direction. In regards to this and a vehicle that we're looking at here, with caster, what we'd look to do is point the suspension in the direction of travel. When we point the suspension in direction of travel, as you can see here through the upper ball joint and the steering pivot, okay, lower ball joint here into the steering pivot, you can see there's an angle pointing in the direction of travel, which is going to be this way. Okay, this way actually, sorry. And that's going to allow the load of the vehicle to push in the direction of travel, keeping the wheels stable. Also, what this helps with is something called self-center steering. So when we let go of the steering wheel, the wheels, when they're being forced in a forward direction, are going to come and they're going to straight and they're going to align. Okay. And the last one that we need to look at in regards to geometry is swivel axis inclination, or what is otherwise known as kingpin inclination. So if we have a look at the diagram, what we can see is that there is a suspension strut. This is a McPherson strut, of course. We're looking from the front of the vehicle, and we can see the road wheel. Now what we're looking at is we're looking at the angle between the suspension when viewed from the front and the road wheel. And what this does is this allows us to have a look at something called the pivot radius. Now the pivot radius is effectively the distance between the offset. So the offset is the angle that comes down from the suspension in correlation to the angle that comes through the road wheel. And what we find there is that the angles collide or intersect below the road wheels. They don't actually intersect on the wheel or on the hub or anywhere that we can see on that vehicle. What that means is it gives a gap or an offset, we call that, between where the line would have been for the suspension and where the line is for the wheel. And that's our radius. That is a radius for a circle at which we'll be able to turn, and the contact patch of the tyre which turns on those wheels. So obviously it's very, very important to give us a positive steering feel and to make sure we can articulate the vehicle correctly, that we set the SAI absolutely perfectly. If we get it wrong, it can make it too stiff. If we get it wrong the other way, we cannot have enough contact patch of tyre to the road, which can obviously compromise our vehicle when we're going around a corner in regards to creating a big slip angle, and then obviously causing the vehicle to understeer or oversteer depending on which way we're going. So that is SAI. Obviously, a final point is it does assist the caster in allowing self-centering. So it's something that obviously assists the caster in making sure we can self-center the steering wheel. So that's steering geometry for level 2. I hope that's helped, and we'll move on to steering components in the next video. Thank you.